powered by artificial intelligence.
RuView is one of those projects that makes you stop scrolling, because the pitch is wild. Use ordinary Wi-Fi signal disturbances to detect presence, movement, breathing, heart rate trends, and room activity, without cameras or wearables. The exciting version is obvious: cheaper ambient sensing, better elder care alerts, robots that understand rooms, and privacy-friendly monitoring where cameras feel intrusive. The careful version is just as important. If a system can infer people, vitals, bathrooms, sleep, and identity-like signatures through radio reflections, then it deserves the same serious treatment as a sensitive sensor network. The system can detect people through walls, count occupants, track entries and exits, measure breathing and heart rate trends, recognize activity, and monitor sleep. Those are big claims, so throughout this review I am going to say when something is the project's claim versus something independently proven. RuView is not only saying we made a sensor. It is trying to publish usable events into Home Assistant, Matter, Apple Home, Google Home, Alexa, SmartThings, MQTT, and AI agent tooling. That matters. A sensor that never leaves the lab is interesting. A sensor that can trigger a care workflow, a light, an HVAC routine, or an alert is much more useful. The strongest advantage is the local first direction. The README says RuView can run on edge hardware with no cloud, no cameras, and no internet required. If you are going to deploy ambient sensing, local processing is exactly the direction you want. Cameras reveal faces, clothing, interiors, screens, children, visitors, and every messy detail of a room. Wi-Fi sensing can potentially infer the thing you care about while avoiding image capture. The use cases are easy to understand. Elder care could use no camera fall risk and inactivity signals. Smart homes could react to occupancy without putting cameras in bedrooms or bathrooms. Robots could understand where people are without needing perfect line of sight. Industrial sites could watch for motion, safety, and occupancy patterns in areas where cameras are unreliable or unwelcome. The second advantage is cost. The README talks about ESP32 class nodes and edge hardware, with claims around small quantized models and affordable deployments. If the sensing pipeline works reliably in real homes, that cost profile would be a big deal. A low-cost mesh of radio sensors could cover places where cameras are not acceptable and LiDAR is too expensive. The architecture is ambitious. RuView is not a tiny demo repo. It includes firmware, Rust crates, Python tooling, dashboards, docs, ADRs, Home Assistant and Matter surfaces, a BFLD privacy layer, and an MCP-style bridge for AI agents. The repo also includes its own demo assets and screenshots, which helps because the project is trying to show a whole stack, not only a paper claim. Now the part that makes this a review instead of a hype piece. The project's own README documents a major live pipeline gap. The pre-trained model is described as available through Hugging Face, but the README says the live sensing server model flag expects a binary RVF format, while the Hugging Face model ships in SAML RVF format. It says pointing the server at that SAML model currently errors and degrades to null output, so for live sensing server use, the current guidance is to run without the model until an adapter lands or a binary model is republished. There is another important maturity caveat. The README says the separate 17 keypoint pose estimation model is not in the release yet, even though the pipeline is implemented. That matters because demos, diagrams, and future architecture can make a system feel more complete than it is. For a viewer or builder, the right question is always, what runs today, what is wired today, and what is still roadmap? ADR 136 is refreshingly direct. It describes a recent series as a skeleton and nervous system, not a shipping product, and says most of that series is not yet wired into the live 20 Hz pipeline. That is not a takedown. It is useful honesty. My read is that RuView is best understood today as an ambitious open-source sensing stack with serious building blocks, not a plug-and-play consumer product. Privacy is the heart of the review. The upside is real. No camera stream means no faces, no visual interiors, no screen reflections, and fewer of the problems that come with stored video. Local processing also reduces the need to ship sensitive raw data to a cloud service. If you compare this with a camera in a bedroom, hospital room, bathroom-adjacent space, or care facility, camera-free sensing has a clear human advantage. But no camera does not automatically mean low risk. The README says camera-free deployments avoid privacy regulations around video or imaging by design. I would phrase that much more carefully. Presence, sleep, bathroom occupancy, possible distress, heart rate trends, breathing, and movement are still sensitive. In many settings they can become health, workplace, tenant, visitor, or biometric adjacent data. The biggest privacy concern is invisibility. Cameras are obvious. A Wi-Fi sensor is not. A visitor, roommate, employee, patient, or neighbor may not know that radio reflections are being used to infer behavior. Through-wall sensing makes that notice problem sharper. If a system can observe beyond the visible device boundary, consent and scope become central design issues. The second concern is identity. The README lists person re-identification as a capability. Each person disturbs Wi-Fi in a slightly different way, creating a personal signature. That is technically fascinating, but it is also exactly the kind of feature that can become surveillance if deployed casually. Even without camera footage, re-identification plus room history is a sensitive record. To be fair, RuView is clearly aware of this. The BFLD layer described in the README and changelog is designed to prevent raw beamforming data from leaving the node, keep identity embeddings in RAM only, and make cross-site correlation hard with key daily hash rotation. That is a strong design direction and one of the reasons the project is more interesting than a simple sensor demo. But the privacy boundary is not perfect. The project's own ADR 140 says semantic states lack fields like evidence references, confidence, expiry, and privacy action. The MQTT privacy code says semantic primitives stay enabled in privacy mode because they are inferred states, not raw biometric values. That means privacy mode can suppress raw biometrics while still allowing states like bathroom occupied, possible distress, fall risk, sleeping, no movement, or room active to move through the smart home layer. The security story is mixed in a constructive way. On the plus side, the changelog shows real security work. OTA uploads now fail closed when no pre-shared key is provisioned. Path traversal was patched in multiple sensing server endpoints. Credential exposures were remediated. Insecure WebSocket handling was fixed. And the MCP bridge defaults to localhost with origin checks and optional bearer token auth. That is good engineering maturity. On the concerning side, the same changelog tells us the attack surface is real. Before fixes, a freshly flashed node could accept firmware over plain HTTP from any host on the Wi-Fi, and unauthenticated callers could reach path traversal paths in the sensing server. The current server also keeps API bearer auth opt-in. When RuView_API_token is unset, the middleware is a no-op and the API remains unauthenticated for the LAN-style deployment posture. So the deployment advice is simple: keep it local, set the API token, use privacy mode, prefer localhost binding where possible, do not expose it to the internet, segment sensors onto an IoT network, lock down MQTT, use TLS or mutual TLS where supported, and be clear with people in the space about what is being sensed. Treat it like a biometric adjacent sensor, not like a harmless Wi-Fi gadget. The developer question is whether RuView is worth watching. My answer is yes. It is exciting because it joins three trends at once: Edge AI, ambient sensing, and smart home automation. It is also interesting because it openly documents a lot of its rough edges. The repo is full of ADRs, test notes, status tables, and security fixes. That gives reviewers something better than marketing copy. The biggest disadvantage is complexity. Wi-Fi sensing is environment sensitive. Walls, furniture, router placement, multipath, people count, pets, humidity, hardware, calibration, and interference all matter. A model that looks great on one validation set may not generalize cleanly to every apartment, care facility, warehouse, or office. For serious use, you want independent benchmarks, repeatable setup guides, false positive rates, false negative rates, latency under real motion, and clear calibration UX. My verdict: RuView is a highly ambitious, high-energy project with real potential and real caveats. The upside is big, cheap, local, camera-free sensing that plugs into automation systems. The downside is also big, sensitive behavioral inference, identity-like signatures, through-wall observability, and a stack that still has integration gaps. If you are a researcher or builder, it is absolutely worth studying. If you are deploying it around real people, slow down, get consent, lock it down, and document exactly what leaves the node. Final line for viewers: RuView is not just Wi-Fi that sees. It is a reminder that the next generation of sensors may not look like sensors at all. That is exciting. It is also why the privacy and security story has to be built in from day one.